Welcome back to Green Dolphin Science. We've got another deep dive for you today.
We do indeed.
And this time, we're looking at Italy, exploring some, well, really fascinating research into new psychoactive substances, NPS.
That's right. They've been using this really innovative technique, urban wastewater analysis.
Wastewater, so like looking at sewage.
Essentially, yes. To understand how prevalent these newer drugs are across the whole country. It's based on a scientific paper, nationwide investigation on the use of new psychoactive substances in Italy through urban wastewater analysis.
Okay, so we're digging into that study today. What are we trying to sort of understand from it?
Well, the goal is really to unpack what MPS actually are, why monitoring them is such a challenge, and how this wastewater approach, they call it WBE, wastewater-based epidemiology, how it gives us these unique insights.
Right, so finding out what the study revealed about MPS use in Italy, which drugs, where maybe one without getting lost in, super technical details.
Exactly, a clear view from the sewers, so to speak.
Yeah, okay, let's start with the basics then. NPS, new psychoactive substances. What falls under that umbrella?
Think of them as drugs that really started emerging around the mid-2000s. They were often marketed, sometimes quite openly, as legal alternatives to established illicit drugs.
Like legal versions of cannabis or cocaine?
Precisely. Things like cannabis, cocaine, MDMA, amphetamines. You might have seen them labeled as legal highs, maybe bath salts, or research chemicals.
Ah, right, bath salts. I remember that term. So they're designed to mimic the effects.
Yeah, they try to give similar effects, but have just enough chemical difference to, at least initially, bypass existing drug laws.
Clever in a way, but sounds dangerous.
It is, and it's a huge global issue now.
Yeah.
By the end of 2021, believe it or not, over 1,100 different MPS have been spotted worldwide.
1,100, wow.
And just in Europe, the EMCDDA, that's the European Monitoring Center for Drugs and Drug Addiction, they had logged 830 by the end of 2020. And get this, 46 completely new ones were reported just in that year.
That's incredible. It's like a constantly shifting landscape. Are there main categories?
Yeah, common ones include synthetic cannabinoids, trying to mimic cannabis, and synthetic cathinones, which are stimulants, sort of like amphetamines or MDMA.
Yeah.
But a really worrying trend is the rise in synthetic opioids, like fentanyl analogues.
Fentanyl analog, yeah. You hear a lot about those causing major problems, especially in North America.
Exactly. Extremely potent and dangerous.
So, trying to keep track of all this, it must be a nightmare for health authorities and police.
Oh, absolutely. It's the sheer number, how fast they appear and sometimes vanish, plus a lot of it is sold online. Traditional methods like surveys or seizure data, they struggle to keep up.
Which is where the wastewater comes in, this WBE idea.
Precisely. Wastewater-based epidemiology. It's a way to get a population-level snapshot of drug use by analyzing, well, the collective excretions in urban wastewater.
So it's anonymous, but gives you a broad picture of what's actually being consumed in a city or region.
That's the idea. It complements the traditional methods really well. It can provide objective data quite quickly on geographical patterns and trends over time.
And this Italian study, how did they apply it?
They collected wastewater samples from 33 Italian cities, a good mix of large and smaller ones right across the country. This was back in October, November 2020.
33 cities, that's quite comprehensive. What were they specifically hunting for in the water?
They targeted 62 specific MPS biomarkers.
Biomarkers, like the chemical traces left behind after the body processes the drug.
Exactly. The parent drug, or its metabolites. These were spread across 8 MPS categories, and importantly, that included looking for fentanyl analogues.
And the aim was, what? To prove the method worked and then see what the patterns were?
Pretty much. Develop and validate the detection method for these substances in wastewater, applied nationwide, and then assess, where use was higher or lower, and if usage changed between weekdays and weekends.
Okay, the big reveal then. They analyzed all this wastewater from 33 cities. What did they find?
Well, out of the 62 biomarkers they were looking for, they actually detected 10.
10, okay. Which categories were most common?
The ones that showed up most often were synthetic cathinones and tryptamines.
Let's pause on fentanyl for a sec. Given the concerns, what was the picture there in Italy based on the study?
It's quite interesting. They did find fentanyl itself and its main metabolite, norfentanyl.
Okay.
But, and this is key, at very low concentrations. Fentanyl was in 9 cities, norfentanyl in 11. The slightly higher presence of norfentanyl suggests it was likely consumed and metabolized.
And this was the first time they looked for it this way in Italy.
Yeah, first time investigating fentanyl and its analogues, specifically via wastewater analysis nationwide there.
And crucially, what about those dangerous analogues? Did they find any?
No, none of the targeted fentanyl analogues were identified in any of the samples.
Really? That seems significant given the situation elsewhere.
It is. It definitely contrasts with findings from wastewater studies in places like the U.S. and Australia, where certain analogues have shown up.
Okay, that's a key finding. What about the synthetic cathinones then? You said they were common.
Right, so the most widespread one detected was methcathinone, or METC, found in all 33 cities.
All of them, so that's widely used.
Well, here's a complexity. The researchers add a note of caution. METC can also come from the breakdown of ephedrine or pseudoephedrine.
Ah, like from cold and flu medicine.
Exactly. Common over-the-counter stuff. So while some METC might be from illicit use, it's hard to disentangle it from medicinal sources without more research. Its presence isn't automatically proof of illicit drug use.
That's a really important nuance. Okay, what other cathinones?
The second most common was 3-methylmethcathinone, 3-MMC, that was found in 14 cities. Its use isn't entirely new to Italy. It was first flagged there back in 2013.
Okay.
Then there was mephedrone, MEPH. That only popped up in 2 cities, both near Slovenia. And that fits, actually, because previous studies had found it in that area.
Interesting geographical link. Any others?
Yeah, methylone, METL, and 4-methylmethcathinone, 4-MEC, were also detected, but only in a handful of cities and likely at lower levels.
Got it. And the other main category you mentioned was tryptamines. Tell us about those.
Right, tryptamines. N-dimethyltryptamine, NN-DMT, was found in 32 out of the 33 cities.
Wow, nearly everywhere.
Yeah, suggesting pretty considerable use, or at least presence. The EMCDDA has also reported increased interest in DMT. Another one, 5-methoxy-N-dimethyltryptamine, or 5-MeO-DMT, turned up in 18 cities.
What kind of substances are these typically?
They are often known for their psychedelic effects. Some occur naturally in plants and animals. Others are synthesized.
Okay. And there was one other category detected, phenethylamines.
Just one from that group,
Yeah.
paramethoxymethylamphetamine, or PMMA, and only in 2 cities at low concentrations.
Right, so we have a list of substances found. Did the study show any patterns about where in Italy use might be higher?
Generally, yes. The overall amounts, the mass loads, tended to be a bit higher in the bigger cities compared to the smaller towns,
That makes intuitive sense.
especially for the stimulant-type drugs, the synthetic cathinones and that PMMA.
What about fentanyl and norfentanyl? Were they clustered anywhere?
Not really. The levels were pretty similar across the different cities where they were found. Lowest in one place, highest in another, but overall relatively consistent. And, importantly, much lower than levels reported in studies from, say, Australia.
Okay. Were there any specific hot spots for the other drugs? Like, City X had way more of substance Y.
Yeah, there were some standouts. For example, the highest average levels for 4-MEC were seen in Turin. For 3-MC, Bologna showed the highest average load.
And the tryptamines.
NN-DMT was highest in Ancona, and 5-MeO-DMT peaked in Aosta. So some regional variation for sure.
Interesting. Okay, what about when people might be using these? Did they look at weekly patterns, weekdays versus weekends?
They did. For fentanyl and norfentanyl, there wasn't really a significant difference between weekdays and weekends.
Which might suggest more constant use, maybe related to pain management rather than purely recreation.
That's a plausible interpretation, yeah. But for most of the synthetic cathinones, for MEC, METL, METH, and 3-MMC, and also for PMMA, usage was clearly higher on the weekends.
Oh, the recreational pattern.
Exactly. Suggests use in social or party settings. For 3-MMC, for instance, the levels detected on weekends were more than double the weekday levels in several cities.
That's quite a jump. What about the tryptamines, DMT, and 5-MeO-DMT? Did they show a weekend spike too?
Surprisingly, no. There wasn't a clear weekly variation observed for them.
Huh. Why might that be, if they're used recreationally?
Well, the researchers raise an interesting possibility, particularly for NN-DMT. It can actually be produced endogenously.
Meaning the human body makes it natural.
In small amounts, yes. So that background level of natural production might potentially obscure or smooth out any specific pattern related to weekend recreational use. It makes it harder to interpret the wastewater signal just for recreational use.
Fascinating. Our own biochemistry adding complexity to the analysis. So the study gives us a lot, but like all research, I assume it has limitations.
Oh, definitely. And the authors are upfront about them. Firstly, targeting 62 NPS biomarkers sounds like a lot, but remember, those 1,100 plus substances identified globally.
Right, it's still just a fraction of what could be out there.
Exactly. So they suggest future work might benefit from combining this targeted analysis, looking for specific known chemicals with broader, non-targeted screening methods. Kind of like casting a wider net to see what else you might catch, even if you don't know exactly what you're looking for beforehand.
Makes sense. What else?
Another point is about metabolism. Mostly, they looked for the parent drug of the substance as it was consumed. Fentanyl was an exception where they also looked for norfentanyl.
Why not look for metabolites for everything?
Often it's because for many of these new psychoactive substances, we just don't have a complete understanding yet of how the body breaks them down. And even if we did, the specific analytical standards, the reference chemicals needed to detect those metabolites in the lab, might not be readily available.
So more research needed on NPS metabolism itself.
Absolutely crucial for getting a more complete picture from wastewater.
And the market itself changes so fast, right?
That's a huge challenge. What's popular this year might be gone next year, replaced by something new. So the study emphasizes the need for long-term, continuous monitoring, not just one-off snapshots.
Keep tracking over time to see the trends.
Yes. And also, international collaboration is key, because these drugs cross borders, but the laws controlling them can vary significantly from country to country.
Good point. Anything else for future research?
They also suggest comparing NPS use with the use of more established illicit drugs like cocaine or heroin, and even older NPS, to understand the bigger picture of drug consumption patterns.
Okay. So wrapping this up, this Italian wastewater study, this deep dive, it really gives us a unique snapshot, doesn't it?
It really does. It highlights the presence of certain synthetic cathinones and tryptamines across Italy, gives those first tentative wastewater insights into fentanyl use there.
And those interesting geographical and weekly patterns.
Yeah, and that finding about the absence of fentanyl analogues compared to other countries is particularly noteworthy.
Definitely something to watch.
It really underlines how powerful this wastewater analysis technique can be. It's objective, it's timely, and it complements those traditional data sources like surveys or police seizures really well.
So it leaves us thinking, doesn't it? As this drug landscape keeps evolving, what else might be out there flying under the radar?
Exactly. And how can insights like these, pulled literally from the wastewater beneath our feet, help inform smarter public health strategies? How can they help prevention efforts and support systems, maybe even in your own community?
It's definitely not the end of the story.
Not at all. This Italian study is really just one chapter in a much larger ongoing conversation about understanding drug use in the modern world.